Good morning, everyone. I'm Povitha from BTech IT B section. Today, I'm here to speak about one of the most useful and fascinating devices in electrical and electronic engineering, which is the inverter. In our daily lives, electricity plays an essential role. Most of the devices we use, like lights, fans, TVs, refrigerators, and computers, run on AC supply. But there are many situations where only DC power is available, such as in batteries or solar panels. So, how do we use AC appliances when we only have DC power? That's where an inverter comes into action. An inverter is an electronic device that converts direct current into alternating current of the required voltage and frequency. In simple words, it makes the power stored in batteries usable for our household and industrial devices. Principle of operation. The basic principle of an inverter is switching. It uses electronic components like transistors, IGBTs that switch the current on and off rapidly, producing an alternating flow of current. These switches are controlled by an oscillator circuit that generates pulses at a specific frequency, usually 50 Hz for our main systems. This alternating DC is then sent to a step up transformer which increases the voltage, for example, from 12 volts DC to 220 volts AC. This AC can then be used to run household appliances. It is the circuit diagram for an inverter. Here, 12 volt DC input is given. It may be either battery or any solar panels. Here we are considered a battery. So 12 volt DC input is given for battery, which provides constant DC input. Oscillator circuit, which generates gate pulses to control switches. Switching circuit will alternate current direction through transformer winding. Next, transformer will set up low DC voltage to high AC main volt. Filters like capacitors or inductors smooths the waveform to reduce harmonics. Finally, the AC output is the final usable alternating supply. The working of the inverter is: first, battery supplies 12 volt DC. Oscillator produces alternating pulses, example 50 Hz. MOSFET switch alternately and creates alternating current in transformer primary winding. Transformer sets up 12 volt AC pulses to 220 volt AC. Filters like capacitors and inductors smooth waveform and which produces pure or modified sine output, which is one of the types of inverters. Then finally, the output power, which is 220 volt AC output, will helps to glow our light. The main components used in inverter are battery, which supplies DC power. Here we have considered a 12 volt battery, then oscillator, switching devices like MOSFET, IGBT, which are the fastest electronic switches, and transformer setup, which is used to convert low voltage DC pulses into high voltage DC, and diodes, capacitors for reducing ripples, an inductor, load. Here we have considered a light which consumes AC power. The main advantages of inverters are: it converts DC from batteries, solar panels, fuel cells into useful AC, ensures backup power in case of mains failure, portable and flexible. Pure sine inverters can run sensitive loads, can be integrated with renewable energy systems. The main applications of inverters are home UPS systems, solar power plants, electric vehicles, industrial motor speed control, emergency power supply. There are three major types of inverters: just square wave inverter, modified sine wave inverter, and pure sine wave inverter. Based on output waveform, square wave inverter will be simple and cheap, low efficiency, and noisy. And modified sine wave inverter is better than square but still not perfect. Pure sine wave inverter will be high quality. Finally, the inverters are essential for modern power needs and widely used in renewable energy and backup systems. In future, it becomes smart
and IoT based inverters. Thank you.